Have you ever stopped and really thought about this AI stuff? You type in a question, boom, you get a detailed answer that sounds human. It writes poems, it writes code, it can even produce a research paper in seconds. How does it do that? What is the secret engine humming under the hood for models like GPT from OpenAI and Gemini from Google? It feels like magic, but it isn't. The truth is simpler and stranger than you expect. It all boils down to one bizarre idea. The AI is superb at guessing the next word. That's it. That's the core concept. It's not thinking like us, it's a prediction machine. The first thing to understand is that computers don't read words. They only understand numbers. So the first step is turning language into numbers the AI can work with. This process is called tokenization. You might think you could assign a number to every word, but that would be huge and inefficient. Instead, the AI breaks words into common, meaningful parts. For instance, unhappy splits into un and happy. Token, un, token, happy. This keeps vocabulary manageable and teaches language-building blocks. Un often means the opposite. Ing marks ongoing action. New word, webinarification, don't panic. It splits into known parts to infer meaning. That makes it adaptable to slang, new terms, even typos. But tokens are just IDs. They don't capture meaning. Enter embeddings. Each token becomes a long list of numbers. It's vector. Think coordinates on a massive map. Similar words land close together. King near queen, walking near running. Each number encodes an abstract feature the model learns during training. Transformers look at all words at the same time, fast, but no built-in order. Without order, these look identical, but the meanings are not. The fix is a clever trick called positional encoding. We add a position vector to each word's embedding. Now the model knows meaning and place in sequence. So dog in position 2 versus 4 is distinct. That gives a sense of grammar and structure. Now the heart of the transformer, attention. It learns which words matter most to each other to understand context. For every word it builds 3 vectors. Query asks, key labels itself, value supplies the information. Attention helps it point to the ball, not the robot. Scores guide a weighted blend of values, producing a context-enriched vector for each word. And during generation, it can't peek ahead. Masked attention prevents cheating on future words. Bottom line, attention lets the model see relationships across the whole sentence at once. One attention view isn't enough. Language has many relationships. Bank relates to cash here to river there. So transformers use multi-head attention, multiple attention heads in parallel. Each head learns a different lens. Grammar, roles, pronouns, style, more. Their outputs are glued together, then compressed back to size. Split into heads, compute in parallel, combine the insights. This untangles complex text. Older models read linearly. Transformers see many connections at once. That's why models from Anthropic and xAI's Grok handle long, complicated prompts so well. After all that math, we risk losing the basics, meaning, and position. The fix is simple and genius. A skip connection adds the original vector back in. It's a highway around the block so the core signal isn't lost. Then layer normalization cleans and stabilizes the values for smoother learning. Next, a small feed-forward network lets each word think independently. It digs for deeper patterns using the fresh context. Then we add the input back again and normalize. Preserve the signal, keep training stable. This cycle, attention, add and norm, feed forward, add and norm, makes one decoder block. One block isn't enough. Models stack dozens, even near 100. Each block refines understanding a bit further. For generation, we only use the final vector of the last word. A final linear layer turns it into scores for every possible next word, then softmax makes them probabilities. It can pick the top score, or sample from the top few for variety. That's how it makes its guess. Training starts as random numbers, No knowledge. We feed it massive amounts of text and ask for the next word. Early guesses are terrible, so it computes an error. Backpropagation traces which numbers caused the mistake. Gradient descent nudges them a little toward better. Billions of loops later. Zooming out. Tokens become vectors, positions add order, attention adds context, over many blocks. After enough blocks, it guesses the next word, again and again. This architecture fuels the AI explosion. It's why NVIDIA, led by Jensen Huang, builds giant GPU supercomputers. Why Satya Nadella at Microsoft doubles down on AI. Why Sam Altman pushes the frontier at OpenAI, and why Elon Musk's xAI trains Grok. Attention spots connections across long stretches of text. That's the leap. For language, attention really can be all you need. But remember, it's predicting, not thinking. It can be confidently wrong, hallucinating plausible nonsense. It can inherit and amplify bias from its data. So we meet this moment with wonder, and with safeguards. The question now isn't just how it works, but how we choose to use it.